SuperFlow 1020 Flowbench is the industry standard of flow benches. It is also the best-selling flow bench in the PowerTest product line. In this video, we will go over the key components of the flow bench, as well as calibration. The flow bench itself is fairly simple in both design and operation. It consists of a base plate to which parts can be attached for testing, as well as test plates of different sizes for calibration. The FlowCom control panel is where the user operates the flow bench and can make changes to calibration and configuration. The storage compartment is where the motor controller can be found. Shown in this image, the power cable is connected to the back of the flow bench. Normally it would be routed through a hole in the bottom of the flow bench, and a plate would cover this connection. The intake and exhaust capacity of the flow bench is approximately 1000 CFM at 25 inches H2O pressure. It requires 240 volts AC, 75 amps single-phase power, and is 48 inches in length, 43 inches tall, 33 inches wide, and weighs 563 pounds. In order to confidently commission a flow bench, it is important to know some key points about what a flow bench does. The 1020 is capable of both intake or exhaust, and the bench measures the difference in pressure across the base plate or any part attached to this base plate. Flow bench flow is volumetric flow, as though testing at 70 degrees Fahrenheit at 29.92 inches of mercury, otherwise ideal conditions at sea level. As air is moved through the flow bench, it passes through a measurement orifice. The difference in pressure is calculated by probes attached to transducers on the FlowCom circuit board. Contrary to assumptions about corrections needed per changes in air density or weather, the flow pressure will always be the same as long as the properties of the part or bench do not change. A PDF report can be provided explaining this fact. Controlling to a difference in pressure performs the air density correction itself. Controlling to a rate of flow is actually controlling to a flow pressure. No correction for air density is needed for accurate readings. Simply put, by selecting a test pressure, an operator is able to determine how much air can flow through a part in units of CFM, or cubic feet per minute. By selecting a flow rate, an operator is able to determine the pressure buildup caused by resistance to airflow in the part. Testing beyond the actual capacity of the flow bench is possible. For example, an operator sets for 28 inches of water test pressure. The motor controller PID loop sags a little bit, and the actual test pressure is 27.89 inches of water. The part flows 100 CFM at this test pressure, which is below the set point pressure. The FlowCom knows that the test pressure is slightly below that of the set point. The FlowCom estimates what the flow would be as if the test pressure had met the set point. The FlowCom will do this up to 50% below the set point test pressure. More than 50%, the FlowCom will refuse to estimate the flow. Pictured right is the FlowCom control panel. This control panel has 4 ports on the left that should be addressed. The first is the serial port, which is meant for a swirl meter. Wiring for this can be found on page 2-6 of the SF-1020 manual. Next to this is a plug for a foot pedal, which the operator can use to operate the flow bench. P2 allows the operator to test pressures outside of the flow bench, and P3 is used for testing of velocity probes, or pitot tubes. Refer to the SF-1020 manual for more information on these ports. On the right side of the keypad, you'll find the power on-off switch, the motor on-off switch, and the intake and exhaust switch. Pictured, you can see that the intake is selected. The function buttons allow for menu navigation, and anytime you enter into a menu, F1 is the back button. Navigation arrows allow you to navigate through the menus, and the enter key allows you to make selections. What's left is the number pad. These numbers allow you to enter raw data or change the orifice range. In order to prepare the flow bench for calibration, we'll need to reset a few default settings. While the bench is off, hold down 4 on the number pad and press power. This should bring up a menu that allows you to select the flow bench type. Select SF-1020 and press enter. When it asks about orifice calibration, select Yes and hit Enter. Default calibration, make sure you select No. If you select Yes, this will set all calibrations back to factory defaults, including transducers on the circuit board. When it asks about default full-scale flow, select Yes. After orifice calibration, you'll see data displayed on the home screen. TP, test pressure, flow rate, and velocity are shown. Press F2 and go down to Restore Cal. When asked to restore cal from flash, select Yes. Back on the home screen, you see that I have TP, flow, and temp1 selected. You can use the arrows to select which sensor you would like to change and press Enter to change the sensor. In order to get accurate calibration data, you'll need to use this Excel document with a laptop while testing. The document can be found under SuperFlow Colorado's iDrive, Test Department, Flowbenches, and then in SF-1020, the file name is 1020 normalized 25 inches H2O cal. This document is used to input flow rate readings at 25 inches H2O pressure using different test plates and different orifices to calibrate the SF-1020. There are 16 different calibration plates PowerTest keeps stored in a wooden box. These plates can be sold to customers, but are typically rented to customers or sent along with a technician to a customer location. Here below, calibration plate 3 is shown installed on the base plate with the provided thumb screws and gasket. Notice the markings toward the top of the plate. These are its identification numbers. When testing in intake mode, the plate must be installed with these numbers facing up. From the main menu, press F3 to enter into the test menu and select Servo Mode. Make sure pressure is selected. Then, back in the test menu, select Servo Value. When in this menu, set the test pressure to 25 inches H2O and press Enter. Back on the main menu, we can see the bench is being flowed and a test pressure of 25 inches H2O is stabilizing. The flow rate is shown as 94.6 CFM and the temperature of the motors is 104 degrees. After an orifice plate is flowed in a particular range, the flow rate needs to be recorded in the calibration Excel document. Shown along the bottom are the sheet tabs used depending on the type of calibration being performed. Right now, intake calibration is selected, followed by intake final, exhaust calibration, and exhaust final. The tabs labeled intake final and exhaust final are used to record the leakage of the particular bench. We will discuss what this means later. After the flow rates are recorded in the calibration tabs, correcting numbers are generated in the calibration report tab. These numbers are entered into the flowcom to calibrate the bench. These orifice numbers along the left correspond to the calibration plates, while the numbers shown along the top correspond to the flow ranges of the bench. The flow rates found while flowing the bench with an orifice plate in a specified range are recorded along this diagonal in its respective box. The flowcom panel on the right shows that a range of 3 is selected. The flowcom also shows a stabilizing pressure of 25 inches H2O and is flowing at a rate of 94.6 CFM. Comparing this with the expected numbers of the Excel document, we can see that this is close to how the bench is expected to perform. Coming back to recording the leakage of the bench, notice there is a box for recording it at the top of the Intake Calibration tab, and similarly on the Exhaust Calibration tab. It should be noted that recording leakage here should be ignored, as the correcting numbers use a similar box on either the Intake Final or Exhaust Final tab, depending on the type of calibration being performed. To find the leakage of a flow bench, the customer's test plate provided with the bench can be used. Normally, a rubber plug would seal the larger hole, while you can use your finger to seal the smaller hole. With the flowcom set in range 1 at a pressure of 25 inches H2O, flow the bench in intake mode and wait until the pressure and flow rate stabilize. Record an approximate value of the leakage in the Intake Final tab of the Calibration Excel document in the box provided at the top. it should be noted that the value of the leakage entered into the flow comm of the Flowbench should be set to 0 for this calculation to be correct. Once every box along the diagonal is filled with the flow rates found during testing, the table is complete. Scroll down to the bottom of the page and look at the table labeled % difference of full scale. This is a measure of the calculated difference of the bench compared to what is expected. You will find these percentages along the bottom. The acceptable values here are as follows. Range 1 must be within plus or minus 2%, while all other ranges must be within plus or minus 0.5%. If any range falls outside of these % differences, there is a problem with the bench itself. Once all flow rates have been recorded and the % differences have been verified, switch to the Calibration Report tab. Here you will find the optimized numbers for both intake and exhaust calibration. On the Calibration Report page, find the intake range table. This is where the optimized numbers are found. On the FlowComm main menu, press F1 to enter into the configuration menu. Select Intake FS or full scale to enter these optimized numbers for the respective ranges. Starting at range 1, press Enter to change the CFM to the respective value shown for the optimized range on the table. Continue in this manner until you've completed all through range 10, and press F2 to save. This concludes the intake calibration. In this video, we used intake calibration as an example for instructive purposes. It should be noted that exhaust calibration is performed in the same manner using the Exhaust Calibration tab, with the flow comm set in exhaust mode. The one caveat to this is the calibration plates used must be placed with the identification number facing down instead of facing up. The reason they are placed facing down when in exhaust mode is because the machined edge of the holes on the plates can have a slight effect on the flow rate measurement. Thank you for sticking with me so far. This concludes the calibration overview. Continue watching for a live explanation of the process.
This is the test plate that's shipped with the bench. Customers have this. They usually have a rubber stop that can plug this hole. Before we start entering data into the Excel sheet, we need to verify leakage, which is not done on the intake calibration page. It's done on the intake final page, entered in up here. In order to verify leakage, we would plug the hole with the rubber stop and then slow the bench in range 1. So we just have to press 1, it'll change the range. Once the orifice setup range is set to 1, we're going to set the test pressure. To 25 inches of water. And we would hit flow. We would hit the fan button, it would begin to flow. At that point, we would use the rubber stopper to plug up the larger hole, and just our finger. Wet your finger if you need to, and make sure this is sealed. And with the rubber stopper and our finger plugging these holes, we would be able to give a good leakage value under flow. Whatever this flow says after it stabilizes, you would then come in here and put that value in this field right here. You can see that. Right now we have a value of 1 in there, which suggests there's 1 CFM of leakage in this bench. Now, that's not actually true, because this bench has a leakage of 0.5 from testing it earlier. But we also want to make sure that while we're testing this leakage, that this value is 0. The leakage value in the bench has to be 0 for us to get an accurate reading for the leakage for the Excel sheet. The reason for that is if there is a leakage value in here, it's already subtracting the leakage away, and so you'll get a value of 0 when testing leakage. Instead, we make this 0, we test for leakage, and then we enter that value, into this table here. Now we'll move on to calibration. Here are the test plates. They're test plates 1 through 16. Comes with thumb screws and a gasket. Now test plate 3 I already have set up here, and the thumb screws are in my hand here. I'm going to take off the test plate. This has the gasket already adhered to the plate. I'm going to go ahead and attach. This is test plate 3. Alright, now the test plate 3 is attached to the base plate here. We would come back into this mode. Now one thing I'm going to do is I'm going to actually change this sensor. I want to change this to temperature. Temp 1 is the temperature of the motors and the bench. We would flow this in range 1 at 25 inches of water, which we can verify. Servo value is set to 25 inches of water. And then in intake mode, notice intake, exhaust. In intake mode, we would hit the fan button and it would flow. See, it's coming very close to 25 inches of water. Now I'd call that stable and 10 CFM. Here you can see at 25 inches of water, 25 inches of water, range 1, plate 3. Here we would enter that value, 10. Notice that the value that we're meant to get is 9.7. This value is within 2%, which means it's a good value. If it was too far off, the bench would need to be looked at closer. And we'll go on and do that. Range 1, plate 4, range 2, plate 5 and 6, range 3, plate 7, 8, so on, all the way down. Once it's all filled up, then we'll get corrected numbers. You can see the corrected number shows up here on the chart below, optimized full scale value. This is the percentage difference. So you can see that it's 0.3% difference, or 0.3, sorry, CFM difference. This value here would then be used to adjust the bench, which we would be able to do by going into Calibrate, 3512 is the code. Select channel flow pressure. Okay, this is still calibration plate 3, but say we changed it to 4 and we floated it at the same rate. We would expect to get somewhere around 21.6. Let's say we flowed it at 25 inches of water and got 23 CFM. Now this is going to do a calculation and give you a difference. If you come down to intake final, You can see I've changed the leakage to be 0.5, which is more reasonable for this bench. And see that this range 1% difference at full range scale is 2%. That is okay for range 1. For every other range, this percentage needs to be 0.5 plus or minus or below. So plus or minus 2% for range 1, plus or minus 0.5% for every other range. Once you have these numbers, you'll come down to calibration report, and you will adjust with this value in the bench. So optimized range CFM is 23 in range 1. Using this menu, we would configure, go to intake, since we did intake, not exhaust. Password 3512. Now you can see range 1. We would enter in 23. Sorry, I have to actually hit enter. 23. Enter. Now it's asking for range 2. We haven't done the test for range 2, but if we did, there'd be a number here. It'd be close to 50, and we would enter that number in range 2. Continuing until we have entered every number for every range, and then hit save. Or you could just come to the end here. Now we're range 6, range 7. I believe it just exits out at the end. Yep, save. I'm not going to save though, because I don't want to change the number. Just quit out. F1 is always back. We would have the calibrated flow ranges for this bench. We would do the same thing for exhaust, except in the exhaust setting, we would actually flip the plate over, because the edge here is a machined edge specifically for intake. And so obviously if we have the exhaust setting where we're going to be blowing air out, we want to have the plate flipped over so that this edge faces the airstream.